Hi everyone, this is Fahad Mirza and I welcome you to the channel. Slowly but steadily, Cohere for AI is dropping model after model. This time, they have dropped their vision model, which comes in 8 billion and 32 billion parameter sizes. In this video, we are going to install this 8 billion vision model locally, and then we will try it out with various benchmarks. One of the cool things about this model is that it supports multi languages, which I will be mentioning shortly, and it is quite useful for understanding both visual and textual information. This model is an open weight release, which is optimized for tasks like OCR, image captioning, visual reasoning, text summarization, question answering, and even code generation. Its architecture allows it to process both text and images as input while generating text as an output. It supports a lot of languages from various regions in the world. For example, English is there, Spanish, Mandarin, Greek, Persian, Hebrew, and then Indonesian, Malaysian, and a lot of other languages from various regions such as Polish, Hindi, Greek is there, Romanian is there, and then there are few languages which are not mentioned but they are also included. So in total, officially this model supports 23 languages. The context length of this model is 16,000, which I'm observing is sort of a standard with Cohere's models in most of the cases. Another interesting bit is that it uses siglib2 patch 14 as a vision encoder. When we say vision encoder, vision encoder is a model that transforms visual data into a form that can be processed alongside text by the vision language model. This encoder employs a patch based approach where images are divided into smaller patches and then they are individually processed to capture intricate visual details. So that is a quick introduction of this model. Let's try to get it installed and we will see how it works. Let me also thank Mast Compute who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU on very affordable prices, you will find the link to their website in video's description, plus a discount coupon of 50% for range of GPUs. This is my Ubuntu system and this is my GPU card NVIDIA RTX A6000 with 48 GB of VRAM. Let's start by creating a virtual environment. And now let's install all the prerequisites, especially the transformers from source. This is going to take a couple of minutes, and while that happens, let me also introduce you to the sponsors of the video who are AgentBot. AgentBot lets you effortlessly deploy a personalized knowledge bot across platforms like Discord, Slack, and others. It is ideal for open source tech communities and startups that provide user support, and I will drop the link to their website in video's description. And this is a gated model, so you would need to go to Hugging Face and then accept the terms and condition on the model card, and I will drop the link to it in video's description. So go to Hugging Face in your profile, grab your read token, which is a free token, because we need to log in order to download this model from Hugging Face. So I am logging in with Hugging Face CLI. I just pasted my token and then you can see that my login is successful. Next up, let's run my Jupyter notebook so that we could download and play with this model in my notebook environment. And there you go. Let me now download the model with Hugging Face Transformers pipeline. And the model is being downloaded. There are 4 shards of it. And the model is downloaded. Let's do the inference. So first up, what I'm going to do, I'm just going to give it this image of a bear. And then I'm asking it what is in the image and I'm printing out the response. So let's run this while let's also check the VRAM consumption. So it is consuming over 35 gig of VRAM for an 8 billion parameter model, which I believe is quite high, but maybe due to the multilinguality. Anyway, we will check it out. So I'll just put the image here. And if you look at the response, it is describing it pretty good, like a rocky riverbank and positioned with its back to the viewer, showcasing its muscular build and thick brown fur. The bear's posture suggests it is alert and possibly scanning its surrounding, perhaps in search of food or monitoring. The rocky terrain and the presence of water indicate that this scene is likely set in a natural habitat. pretty good answer, I would say. It has described it quite well without fluffing around. So I would say it's quite a good quality answer. And next up, I'm giving it this mural and I'm asking it, what is the message being portrayed in this mural? Let's see what it says here. Could be anything. And the answer says that the mural portrays a powerful message of self expression and artistic freedom. The vibrant and abstract style of the artwork combined with the bold colors and dynamic composition suggests a celebration of creativity and individuality. The central figure, a woman with expressive eyes and flowing hair, appears to be the focal point. Very nice. And then it is talking about other graffiti elements like urban culture and that sort of stuff. And mural is empowerment, creativity, and transformative power of art. Good stuff. So the visual understanding of model looks quite good as we just saw. I'm very interested as in OCR and especially the multilingual OCR. So what I have done, I have just grabbed a lot of images from different languages, which and most of them are the supported ones, and some of them are in handwriting, and some of them which are not mentioned in their data set. And then I just created this simple, very simple code where I'm iterating through that directory which I just showed you, and then from there, the prompt is that do OCR on this image and extract the text from the image as is. Don't translate it into English. Identify the language of image 2. So I'm running at it at the moment. It is running. So you see, the first it went with handwritten.jpg. So let me take you there and bear with me because this is running in real time. I just wanted to show you it in real time. So this is the handwriting one. Let's compare the handwriting. So it says, I love handwritten letters. There is a dot. The way the words get jumbled up, very nice. Spot on. The way the words get neat when the writer is trying. So you see, there are some cutting. Someone has just cut some words, but I think it has been able to do it pretty nicely. So this is really, I would say, flawless. And then similarly, if you go here, next up is, you can see there's a Persian. So it has got the Persian one. It has detected the Persian. So let me see where my Persian image is. And this is a Persian one. There you go. So if you're a Persian speaking, please help me out with this one. I'll just put it here. I'm just reading through it. I know that the direction of Persian script is different than the English, but still I think we can at least make some educated guess. But as far as I am concerned, to be honest, I can't tell. Some of the words which I can just visually check out looks good, but I'm not sure really. So please, if you're a Persian speaker, help me out here. And then this is the Arabic one. Let me grab the Arabic image from here. I'll just remove this P and then I'll show you the Arabic one. And there you go. So this is Arabic. Now if I visually check it out, I'm not sure. To be honest, I don't think so that this one is good because I see that a lot of repetition is there. So Arabic OCR, I don't think so. I don't even think Persian is good. English is good, and let me quickly show you. English should be good because English is the easiest, I believe. There is, in terms of data set, because they get trained on a lot of stuff there. So if you compare the English quickly, English looks good. And then next one is a German. So I'll just scroll down and then open it here. This is a German one. Let's check out German. Yep, German also looks quite good as far as I can see. It didn't complete it. You see, it just stopped at this Endspricht. Sorry if I'm pronouncing it not good, but I think it should have gone up till here. Maybe due to my context length, that is why. But I think until here it looks good to me. So European languages are quite good. Okay, let's check out Romanian. I'm not sure about Romanian, but let's check. There you go. So this is the Romanian, again a European language, and yep, looks quite good actually. Yep, I think Romanian looks good. You see, it has perfectly done it right. Okay, so then we have this Chinese simplified. So there is Chinese simplified and then there is Chinese traditional. I have done both. Let's check out the Chinese simplified first. And again, it will be hard for me to gauge. It has just done until here. So let me know what do you think. And I'm surprised that it consumed all the context length of my, I think, 500 or something in just these words. But confirm it to me, please, if this is correct. Italian should be good, I believe. Where is Italian? Okay, because European languages, it seems it is quite good in European languages. So if you quickly compare the Italian with it, yes, looks good. Let's go down. Okay, then I gave it a multi.jpg. So what multi.jpg mean here, that what I did, let me show you. I just grabbed a paragraph, I put it in lot of languages in one paragraph, like English, European languages, and even Hindi. And then let me quickly check, it was able to detect, yep, this is a German word, there are some Czech words. I'm just checking if it did the Hindi. I couldn't see the Hindi. You see there is a Hindi in it, but when you mix the language, it is unable to do so. So I think this is a fail in terms of multi-language paragraph. I don't even see the Chinese here, and not even French, or maybe French is bit here. You see striving to live, where it is striving to waver. So if you mix a paragraph with languages, it fails to do so, but separately it was able to detect the same languages. Okay, then I have given it a Czech one, and these are the languages which are all in its supported list. It should have done it. So check. Let's check it out. Testy. I don't think so. You see, if you check at the OCR, even this testy word is not good enough. And then I think it is repeating a lot of stuff in the Czech one. So Czech is a fail. Let's check out Turkish. And sorry if it is taking a bit of a time, but I think this is nature of the test. You have to bear with me. So I'm just going to check the Turkish here. Now you can immediately tell that it is repeating, it is hallucinating. So I'll just close it. Even Korean doesn't look good. Japanese, let's check out Japanese. So if you check at the Japanese, I think it finished it here. But until then, if you look at this line looks okay to me. But if you're a Japanese, please confirm. Okay, Urdu, let me check if it was able to do something in Urdu. Urdu is a language which was not in its data set. Where is it? Come on. Sorry, I think I would have to go back to my OCR. And I would have to grab the Urdu. This is the Urdu one. So for Urdu, because fonts are not installed, so this is one reason. But if I quickly look at it, uh, it's not. It has tried its best, but it doesn't. It is repeating a lot of stuff too. So Urdu is a fail, I would say, and it's not in dataset. We can ignore it. And then there is a Vietnamese which I have done. This is a very beautiful script, as you can see, and it is in its dataset. So I don't think so. It has done it well. I mean, visually I'm checking. You see this Kong word, and there is no Kong here in this one. So I don't think so. Vietnamese is good enough, and it is still printing. I think. Okay, cool. Swahili doesn't work with Swahili. I also gave it that, and then I have given it the runes, which are the ancient language. So these are the runes I gave it with English original, and I'm just asking it to OCR it. The English one is good. You see, it doesn't understand the runes, so it was unable to do that elder Futhark transliteration. So that is fine. That was too hard for it. And Swahili is not good. I gave it a Swahili, which is a very beautiful African language. So it was unable to do in the Swahili one too. You see, this is a Swahili, but it was unable to do it in the Swahili one. Now I think it is finished already. Yep. So you see, you just saw that how it goes with OCR. Some of it is okay, some of it is not. And finally, let's try out if it can understand the tabular data and if it can do a bit of a data analytics. So I'm giving it this image where we have some models and that sort of stuff. And the question which I'm going to ask it, that if a user is limited to exactly 2 GB of memory, which models from the list provided could they run on their local system, and what is the precision setting and required download size of each model? So let's see if it is, because I said 2 GB and I also have given it maybe byte. So let me run it to see if it can do it or not. Also, if you're wondering about the answer here, so it should be Moondream 2 billion in the int 4 precision, and then it could be Moondream 0.5 billion both in int 8 and int 4. So there are 3 models which it can run. So it says, based on the provided table, a user with exactly 2 GB of memory can run the following model: Moondream 2 billion int 8 and Moondream 2 billion int 4. Both of these models fit within the range. Now, if you look at it, Moondream 2 billion int 8 is more than 2 gig, right? So I don't think so. That's a good answer. Int 4, maybe int 4 would fit in, so we will take that one because it fits in. Otherwise, I don't think so it is going to fit in that one. These two fit in, so I don't think so. It has done a good job there. It was able to read the table, but I think data analytics part is not that good. And let me ask it a simpler question then to see if it is able to do that. But I think with 8 billion parameter size, or 8.63 to be exact, and if it takes more than 35 gig of VRAM, I expect a lot better data analytics and also of course the OCR. So I'm just now checking a very simple question, that which model uses the least amount of memory, and it says that the model that uses the least amount of memory is Moondream 0.5 billion, which consume this much at this much of memory. Now, what do you think? Look, 0.5 billion, it says 996, right? Whereas in int 4 precision there is a 816, so it should have mentioned this one. Now, I think it can read, it can do the OCR from tables, but it's hard for this model to understand data analytics and then analyzing the data after extracting it from the table. So for me, I think, okay, so I think Cohere has dropped the ball with this Aya Vision model. I think they should maybe do more training and do some more iterations to make it better, especially again when it comes to VRAM consumption and size. But keen to hear your thoughts on it. Let me know what do you think. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thank you for watching.